Hello and welcome to section 10.7. In 10.7 what we're going to be doing is solving for segments of chords and secants and tangents for circles. So we're not looking at angles, but we're looking at the segments. The first segment we're going to deal with is the chord power theorem, so we'll be dealing with chords. If two chords of a circle intersect inside the circle, then the product of the measures of the segments of one chord is equal to the product of the measures of the segments of the other chord. So here we have two chords, chord CA and chord DB. What this says is if you break the chord into segments, AE, and you multiply it by the other portion of the chord, EC, then that's going to be equal to the other segment's products for the other chord, DE times EB. So let's give it a try. In the left example, we have from P to Z, which is 5, and we have from Z to R, which is 12. For the next segment, we have Z to Q, which is 10, but what we don't know is Z to X. So I'm going to give that the variable X because that's what I'm solving for. So it's the product of the first chord segments, 5 times 12, is going to equal the product of the second chord segments, 10 times X. 5 times 12 is 60. And then we have our 10x. We're going to divide by 10, and we're going to get that x equals 6. So the value of SC is going to equal 6. Let's try it again over here. From P to Z, or P to Z is equal to Z to R. So P to Z is equal to Z to R. S to Z is 8. So we have 8 for this other segment. And Z to Q is 18. Okay, so now we have two unknowns. If they're congruent, I can give them both the same value of X. So it's going to be the product of the two segments that make up P to R. So we have X times X is going to equal 18 times 8. X squared is going to equal, that's 64, so 144. Excuse me, and take the square root of both sides. And I got that X equals 12. So when I come up here, P to Z equals 12. Here's a challenge one that I want you to try. I would recommend you label all of your segments and work from the inside out. So pause your video and give it a shot. The next power theorem we're going to learn about is the tangent secant power theorem. If a tangent segment and a secant segment are drawn from an external point to a circle, then the square of the measure of the tangent segment is equal to the product of the measures of the entire segment and its external part. The entire segment and its external part. So what we're going to do is we're going to square the value of the tangent. Then we're going to take the whole value of the secant and we're going to multiply it by the outside of the secant. Let's start by labeling our sides. F to E is 12. E to D is 4. So what we don't know is our tangent. We'll call that X. So the way it works is it's the square of the tangent is equal to the product of the whole secant, so that's going to be 16, times the outside, which is 4. The outside segment right here. X squared equals 64. I'm going to take the square root of both sides, so X equals 8. If we're trying to find segment E to D, we know that X equals 8. I didn't say E to D. We're trying to find segment S to D. So S to D also equals 8. All right, let's come over here. We have R to S is 8. P to R is 4. We want to find Q to R. So what they're looking for is the entire segment. So we're going to take our tangent and square it, 8 squared, and that's going to equal the entire segment times the outside. So we get 64 equals 4x, divide by 4, x equals 16. Now since we had defined x as the whole segment, because 4 was on the outside, we know that the Q to R value, Q to R, is going to equal 16. Go ahead and solve for this one. Looks like you might have to factor. Our last power theorem is the secant power theorem. If two secants are drawn from an external point to a circle, then the product of the measure of one secant and its external part is equal to the product of the measure of the other secant segment and its external part. So basically you're doing the same thing. Whole times the outside, whole times the outside. That's what you do when you have your secants. And again, it's going to be my whole times my outside, which is going to equal the whole times your outside. That's Mork, in case you can hear him crying. He wants attention. All right, so here we go. U to V is 7. V to D is 5. T to D is 4. We don't know what S to D is. That's what we're trying to solve for. So I'm going to start with the one that has both informations, or both segments. The whole is 12 times my outside of 5, which equals my whole, which I don't know, times 4. So the value of x is for S to D, and that's the whole, which I don't know. 60 equals 4x, so x equals 15. So S to D equals 15, because that represented the whole in our example. On the right, D to C is 8, C to E is 4, B to E is 6, and now they want me to find A to B. Okay, so I'm going to set it up like we've been doing. I'm going to take the whole, so the whole of the segment, 12 times my outside of 4, and set it equal to the whole times the outside, which is 6. So in my example, x right here represents A to E. Pay careful attention, that's not what they're asking for. But this is how I'm going to solve it. So I get 48 equals x times 6, or 6x. I'm going to divide by 6, and I'm going to get that x equals 8. So if the entire segment here, A to E, is 8, then 8, I'm going to subtract the outside, minus 6 is going to give me 2. So in this situation, A to B is going to equal 2. Okay, so I'm leaving another tricky one for you, but I'm going to help you start this one off. We're going to label our parts. O to S is 9. S to T is 9. T to U is 12. And they want you to find U to V. Okay, so in this situation, we need to get the whole, but remember, the whole will go across the entire circle. So give this one a try, and you can check in with me. Thank you.